Find the Z transform of the sequence x of n is equal to a power n un minus b power n u of minus n minus 1 and also specify its ROC. In the last class, we have seen that whenever the signal is given like a power n un, okay, we can write like either 1 by 1 minus a z inverse or z by z minus a, where ROC is mod z is greater than mod a. Or otherwise, suppose if the signal is given like minus a power n u of minus n minus 1, the Z transform is same, but there will be a change in ROC. Okay, Z by Z minus a, but the mod Z value is less than mod a. Okay, the same concept will be applying here. So that means what? We will be writing Z transform for this signal and also for this signal. The time we have to observe this minus for the second term. Okay, because here also minus is there. Okay, so given problem we can write like x of n is equal to a power n un and then plus that minus I will absorb inside. Okay, minus b power n u of minus n minus 1. Okay, so now what is the Z transform for the first signal and also the second signal? Okay, so finally x of n is equal to a power n un plus minus b power n u of minus n u of minus n minus 1. Okay. U of minus n minus 1. So the Z transform of the first signal is 1 by 1 minus a Z inverse. Z transform for the second signal is 1 by 1 minus b Z inverse. But what is the ROC? The ROC1 means ROC for the first term is mod Z greater than a. Again, the ROC for second term ROC2 is mod Z less than b. Okay, why? Because this is the left-sided signal, so definitely ROC will be inside the circle. Again, to be safer side, just put mod value because we do not know what is the value of a. It may be positive or negative, so put mod a and mod. Then again, for this answer x of z to be true, definitely again we have to write the common ROC, because only this term is there we can write this ROC, or only if this term is there we can write the second ROC, but both the terms are there at a time, so we have to write the common ROC. So what is the common ROC? That is ROC1 intersection with ROC2. Okay, so the common ROC is again we do not know what is the nature of A and B. Okay, A may be greater than B or A may be less than B. But if you want to write the common ROC, the only way is the mod Z is greater than mod A but less than mod B. Okay, so mod Z is less than mod B. Again, here it is greater than mod A. So this is the common ROC. So finally, the ROC will be inside two circle. That means there is a circle with the radius A, another circle with the radius B. Again, the region in between is the ROC. Region in between is the ROC. Say again, A value, say this is A, this is B. Suppose if the A value is not less than B, that means if A value is greater than B, okay, so this is true only when A is less than B. Okay, if A is less than B, we can write the ROC like this. Suppose if A is greater than B, what will happen? Suppose in the problem, okay, if A is greater than B, mod A is greater than mod B. Why? Because instead of a variable, they may give us a number also in future. Okay, A as some number, to B as another number, like that they can give. So that time, suppose if mod A is greater than mod B, what will happen? Okay, if mod A is greater than mod B, then definitely you will not be getting any ROC. Okay, if mod A is greater than mod B, that means what you will be doing? Okay, so A circle is here. Okay, again B circle will be somewhere. Okay, so what is the ROC is telling here? Here they are telling mod is at greater than mod A. Again, mod is at less than mod B. Okay, mod is at less than mod B. Okay, so in one way you are telling this is ROC for first signal. Again, in another way, for the second signal, ROC is inside this way because A is larger, B is smaller. Okay, so mod is at less than B means inside this circle. Mod is at greater than A means outside this circle. Suppose if mod A is greater than mod B, then there is no common ROC. Okay, we are not having any common here, so no common ROC. No common ROC, then no is a transform. Okay, if there is no common ROC, then we cannot write this as a transform. Okay, whenever we are getting the more than one signal, okay, if you are getting more than one signal, definitely there has to be a common ROC. If common ROC is not there, we cannot write the Z transform. No Z transform. That means X of Z does not exist. Does not exist. Okay, for this problem directly, I know this formula. That's why directly I applied that formula and ROC directly. But in the exam, whenever you are given the problem like this, you proceed in the same manner what we have did it in the previous class. Okay, you just proceed with that. Similarly, for this also, you just proceed. Finally, you get this conclusion separately. Then you can come to this step finally. Okay, so for the semester exam, don't directly write like this. Okay, as I'm doing here because just we have did it in the previous problem. Okay, so the same exercise we have done it in the previous problem. That's why I have directly taken the result here. Okay, I'm applying that result. Okay, but in the exam, whenever you are given with this question, don't do like this. Okay, just proceed separately. Finally, try to get this answer. So next, find the Z transform of X of n is equal to a power mod n, where mod A is less than 1. Okay, X of n is equal to a power mod n. That means what? A power n when n is greater than or equal to 0, a power minus n when n is less than 0. Then what is X of Z? Summation n minus infinite to plus infinite, X of n is at power minus n. Okay, so again, when n is goes from minus infinite to n is equal to minus 1. Okay, when n is negative, we are having a power minus n is at power minus n plus from n is equal to 0 to infinite. The time we are having a power n. Again, this is at power minus n. Again, in the first term, the index is negative, so we'll change negative index as a positive index. Okay, wherever n is there, put minus n. That means summation n infinite to 1. So we can put like n is equal to 1 to infinite. Again, a plus n is at power n. Is at power n. Then plus summation n is equal to 0 to infinite. N is equal to 0 to infinite. A power n is at power minus n. Okay, what we can do here, summation n is equal to 1 to infinite, a z whole power n, summation n is equal to 0 to infinite, a z inverse whole power n. So again, this summation series is going from 1 to infinite, but actually to get the direct answer, it has to go from 0 to infinite. So once if it is 0, then we'll be getting some extra 1 that we have to subtract. So if it goes from 0 to infinite, definitely the answer is 1 by 1 minus a z. But here we are getting 1, we have assumed 1 extra 1 that we have to subtract here. Here 1 by 1 minus a z inverse. Okay, then 1 by minus 1 plus a z divided by 1 minus a z plus 1 by 1 minus a z inverse. Okay, a z divided by 1 minus AZ plus 1 by 1 minus AZ inverse. Okay, so AZ 1 minus AZ inverse plus 1 minus AZ by 1 minus AZ 1 minus AZ inverse. Okay, AZ minus A square plus 1 minus AZ. So finally 1 minus A square divided by 1 minus AZ 1 minus AZ inverse. Okay, then what about the ROC? ROC1 for this summation series, ROC1 is again this is the right sided one, so mod Z is greater than mod A. Okay, this also right sided one. Okay, we are applying positive time index, so again so we are making some mistake here. Okay, so for first one, again this is not in the standard format, so just AZ, again we know that mod AZ should be less than 1, then that means what, mod Z is less than 1 by mod A. Okay, mod Z. Okay, the AZ has to be less than 1, that means mod AZ is less than 1, then mod Z is less than 1 by mod A. For ROC2, okay, ROC2, this AZ inverse has to be less than 1. So that means what, A by mod Z is less than 1. That means mod Z is greater than mod Z is greater than mod A. Okay, so this implies mod Z is greater than mod A. So ROC1 is mod Z less than 1 by mod A, less than 1 by mod A, and then ROC2 is mod Z greater than A. Okay, ROC2 is mod Z greater than mod A. So then again combinedly we can write like mod Z is greater than mod A, but it is less than 1 by mod A. Okay, this is the common ROC. Okay, common ROC. Again, for this has to be true, again, what is the condition? Okay, what should be the value of A such that it is satisfying this equality? Okay, so definitely the A has to be less than 1. Suppose if A is greater than, say for example, if A is 5, we cannot write like this. Okay, this is completely wrong. But suppose if A is, say for example, if A is less than 1, that is 1 by 5. Okay, if A is 1 by 5, then what is 1 by A? That is simply 5. Then this is okay. So that means what, mod A value for this equality to be true, the mod Z value should be less than, sorry, the mod A value should be less than 1. Mod A value should be less than 1. Okay, under this condition, we can get this. Okay, if mod A is greater than 1, definitely we cannot get the common ROC. We cannot get common ROC. So again, there is no Z transform. So that's why again, if we carefully observe, mod A is definitely less than 1. If you observe the problem statement, they given mod A is less than 1. So definitely we have to write this ROC only. Suppose if mod A is greater than 1, then there is no common ROC, there is no Z transform. Okay, so the same problem we'll try to solve it in the different manner. Okay, so instead of going this way, we'll just try to solve it in a different manner, that is like with the help of the known concept. Other method. Okay, what is the problem? X of n is equal to a power mod n Again, mod A is less than 1. Okay, the same thing we can split up like this. Okay, again, we know that whenever A power mod n is there, okay, A power minus n when n is less than 0, A power plus n when n is greater than or equal to 0. So now what I'm going to do, the same mathematical term, I'm going to write it in terms of equation, okay, with the known signals. That means the first statement I can write like A power minus n u of minus n minus 1. Okay, because this is true only when n is less than 0. Again, the second term is true only when n is greater than 0. So this one I can write like A power n u of n. Okay, here the problem here is we have A power minus n. Generally, we used to have a term like A power plus n. Here it is A power minus n. So that minus I will absorb inside, so that I will be getting 1 by A whole power n u of minus n minus 1 plus A power n u of n. Again, we know that what is the answer for this one. Okay, so the same thing we'll write in the next page. So we have just modified the given equation in terms of like this. So finally 1 by A whole power n u of minus n minus 1 plus A power n u of n. Okay, so now we know that again, whenever the left-sided signal is there, we should have one minus here, so that we can directly like write like z by z minus a. But so here we will include that minus here, z by z minus whatever the number present here, that we have to write it here. The number is 1 by a. So the z transform for this one is minus z divided by z minus 1 by a. Then what is the z transform for this one? Simply z by z minus a, z by z minus a. Okay, so how to proceed further? Again, we have to discuss about ROC also. Okay, what about the ROC1? Again, it's very simple. As it is a left-sided signal, ROC is inside the circle with the radius of 1 by a. Okay, whatever the value present here, that you can write here. Mod z is less than 1 by mod a. What about the ROC2? Again, this is the right-sided signal, so mod z is greater than mod a. Again, what is the common ROC here? Common ROC is mod z greater than mod a, but less than 1 by mod a. Okay, then we'll simplify this. Okay, minus az, or otherwise okay, so divide both the numerator and denominator with respect to z. So minus 1 divided by 1 minus A inverse. Okay, z inverse. Here 1 by 1 minus A z inverse. Okay, so this is the z transform of the first signal minus z by z minus 1 by a, and for the second signal z transform is z by z minus a. Then already we have calculated the ROC, and from this we can take the a up, that is minus za, za minus 1 plus z by z minus a. Then just cross multiply this. Okay, then these two terms cancel. Z we can take out, then a square minus 1. Now in the denominator from the second term, just take z outside, then we'll be getting 1 minus a z inverse, z cancel. Just flip the sign here, just interchange the term. So 1 minus a square, then these two terms will interchange. Okay, then from both the numerator as well as the denominator will be getting minus minus, that will cancel each other. So finally we'll be getting this answer, that is 1 minus a square divided by 1 minus a z into 1 minus a z inverse. The same answer only we got it in the regular method. So 1 minus a square divided by 1 minus a z into 1 minus a z inverse. Okay. So the same problem we have solved in the some two different manner. Finally, it gives the same answer. Okay. Thank you.